Online students, is my voice is loud and clear? Online students, is it clear? Done. Okay, guys. So let's start the session. Now, in this class, we are going to discuss the next topic. Okay. So the last one, whatever we have done is called as decision trees. So let's, before starting a new one, let's continue with the same last one, the decision trees. Okay. So decision trees, we are going to make as a tree type structure and classify the complete data based on the conditions. Okay. It is a based on the conditions, we are going to classify the data based on conditions, classifying the data. Okay. And it is going to have a tree type structure where I'm having the first one called as a root node. Here also I'm going to start with a condition. And this one first we are going to write is called as a root node. And followed by I'm going to take true or false, true on the left side, false on the right side, every time the same. And I'm going to write one more condition. And by writing the multiple conditions, we are going to get till the classifying the data. We are classifying the data till till we get the pure nodes as the answer. So this one, wherever there is a condition, it is called as decision node. And this is also furtherly splitted. So this is also called as a decision node. And after furtherly splitting, and this is finally, whatever the class node we are going to get, this is called as leaf node. And there is no more split, right? So we are going to create a tree type structure, and based on the conditions, we are classifying the data, right? And how to write this condition? How to write the condition? Condition. For writing the condition, first we have to select the variable. Select the variable. And which variable we have to select? Which variable we have to select means select the variable which has either low Jenny impurity, or high information gain, either of high information gain or which is having the low Jenny impurity. Okay. You have to select the variable which is having either low Jenny impurity or high information gain, which either information gain should be high or Jenny impurity should be low. So each time you are going to calculate, each time we will calculate the Jenny impurity of each and every variable of each and every variable. And out of each and every variable after calculation, which is having the least Jenny impurity, that will be selected as our condition node, or which is called as condition node. Which variable will be selected as the conditional node means which is having the low Jenny impurity. This is the one which we have discussed in the last class. With respect to how to calculate the Jenny impurity of each and every variable, and how to calculate the information gain of the each and every variable in the given data set. I have taken yesterday one data set, and in the data set I have told you how to calculate the Jenny impurity of the two columns and how to calculate the information gain of the two columns. And out of that, which one is having the least one, that one you have to select, and then you have to process the things, right? This is the one which we have discussed in the last class. So each time we have to calculate the Jenny impurity of each and every variable, and we have to identify which is having the least Jenny impurity, the variable which is having the least Jenny impurity, variable which has least Jenny impurity will be selected as the decision node, will be selected as the decision node. And we are going to do the process. Now, in the decision trees, we are having a problem. Now, everything was done statistically by calculating the Jenny impurity, the impuritiness of the data, or by using the gainness of the data. We are doing some kind of statistics or max. Okay, we are not selecting the variables randomly as per our choice. We are not choosing the data. We are doing everything as per the statistics, which is having a good amount of data in that information, good amount of information. That one we are going to select. For example, in this class, which student I'm going to give the job. For example, there is a openings in my company. For which student we are going to give the job, means which student is having the good amount of gain of knowledge, right? High gain of knowledge, right? In terms of, so first we are going to check the how for each and every student. I can't conclude that by based on the character or by sitting in the last bench or first bench. I can't decide that the student will have a good knowledge or based on with respect like that. For example, if one of the student is saying every day good morning or good afternoon or something, and if that person is saying like that, means oh, he's having a good subject, we can't conclude like that, right? So we have to take the subject that is entirely a different one, and this is entirely a different one. Though the person is pampering or the person is doing extra things or anything also, that is not considered for the jobs. For the jobs we require only with respect to the subject. Okay, we are having the subject, whether this particular person is going to do the project or not. That is the only important, because for example, one person is doing very high level of pampering and sir, you are great, sir, that one, sir, this one, sir, something he's saying, assume. Now I have selected him. And after once I have selected him in the company, I was not able to complete the project on time. What happens means for him, nothing will happen. For me only, next time, one more new project I will not get. Okay, based on his, I will not get not even one project also. So I have to get my company, I have to get multiple projects, and we have to get with respect to, we have to expand ourselves. Miss, we should not go with the students who are doing pampering or students who are doing that one. We have to identify the students who are having the subject in order to get the expansion of the things. Already we are having the expansion. For example, I'm the Infosys chairman. I'm already having 1 lakh to 2 lakhs crores. For me, one student or two students is not going to be matter. If they waste the money also, for me not matter. For that high level of amount, this is not a matter. But as a startup company, I'm having any company, a small company or my own company, if I'm having miss, for that, I can't take with the students who are doing with respect to any additionals. I want to check in the subject only. For that, for each and every student, I'm going to conduct the entrance test. If it is offline, online campus interviews, miss, first I will take some kind of entrance test. Who are interested only. Who are not interested, we are going to leave. Who are interested, you have to take the entrance test. And after that, I'm going to filter from that. And we are going to conduct some kind of technical round and HR round. And from that, we are going to take the students. And after that, we are going to give some kind of training for them, for the freshers. And later, we are going to keep them in the project. So here, everything, if you observe, in the every step by step, only the subject only will be there. In the first stage of test, aptitude test or whatever the test, there also the subject will be there. Technical round, subject will be there. HR round, the way he handles the pressure or the way he sees the picture, everything, how he is going to react to the original things, that we are going to observe in the HR round. And the once we get into the training, and there also again we are going to see the subject knowledge only. Every time subject knowledge only. We are not going to select based on randomness. Why I'm saying this one means here are the subject knowledge. What are the subject knowledge is there? The subject knowledge is called as information gain. If that particular variable is having some information, we are going to choose that information. If that is not having the information, though it is with respect to very big numbers are there, very small numbers are there, nothing we are going to consider. We are not going to focus on the inside data. We are going to focus overall data. What is the information in that particular column, in that particular variable? What is the information is there? And whether that information is useful for the output variable, how it is correlated to the output variable. We are not going to see how it is correlated to the input to input. We are going to see how it is getting correlated to the output variable, whether it is having any information with respect to output. For example, uh, and and he know the winning and losing, something he knows. Nowadays everyone are participating in everything. Nowadays every person is participating, and they are participating in the competitions. People are participating for the sake that in the regime what we have to get means which is having the more information towards the data science that we have to keep and we have to attract, which is common for others. If you write the same thing in your resume also, it will be common. What is special about you? In the interview, in this class, assume this is the same class. I'm having total, whatever the number of students I'm having, either with respect to, yes, now it is clear, guys. Guys, it is clear now. Still the voice is breaking. Right? Done. It is clear, right? Now it is clear. Still it is fluctuating a minute. Yeah, just give me a minute, guys. Okay. So it makes the conditions for the train data. It will work only on the train data. It is going to make the conditions on the train data, which is leads to the overfitting problem. Okay, and fully Okay, online students, is my voice is clear? Okay, there is a slight network issue, right? So if it is getting disconnected or once again, if it is getting disconnected or something, then we'll stop the session. Okay, I assume it is clear now, right? Done. Okay, so now the decision trees are having, yes, the decision trees are having the con called as overfitting, which is fully grown trees. Means if you go grow ఇప్పుడు ఇంకా ఈసారి మాత్రం బ్రేక్ అయితే మాత్రం వేస్తాను క్లాస్ నా వల్ల కాదు వచ్చిన నుంచి ఇప్పటికో 10 సార్లు క్లియరా అని అడుగుతూ అసలు ఈ టైమే అంతా అయిపోతుంది మొత్తం 20 మినిట్స్ నుంచి ఇదే తతంగం. గైస్, ఈస్ దట్ క్లియర్? Now it is clear? Done. Okay. So fully grown trees, that is till the end. If you extend that till the end, you are going to get the pure nodes. And in that case, we are going to get the overfitting problem. In order to reduce the overfitting problem, okay, if you have the fully grown trees and if you extend that one till the end to get the pure nodes, you are having a problem called as overfitting problem. Now in this overfitting problem, that is fully grown trees, okay, there is a overfitting problem. Now in order to overcome overfitting problem in decision trees, in order to overcome the overfitting problem in decision trees, we are going to do the pruning in the decision trees. In order to overcome the overfitting problem, we are going to do the called as answer is pruning. Pruning means cutting the tree. Pruning means you are going to cut the tree. Cutting the tree is called as pruning. Okay, so cutting the tree is called as pruning. So we are going to do the pruning. Now in order to overcome this overfitting problem in decision trees, whatever, not only in decision trees, generally, okay, generally, if in order to overcome the overfitting problem, or you are trying to get the model, betterization of the model, if you are trying to get the better the model, then it is called as optimization. Now optimization means getting betterization of the model. Okay, so anything, not only this one. For example, linear regression is there. For linear regression, you are trying to get the betterization model, optimizing by using the regularization like lasso, ridge, or elastic net. Or if you are having in terms of KNN, you are going to do the optimization by using the hyperparameter tuning. You are trying to get the better model, betterization for any model. In order to get the better model than the whatever the default model we are having, in order to get the better model, you are trying for any betterizations. In whatever the way you are trying for the betterizations, it is called as optimization. You are optimizing the model. Optimizing the model means bringing to the maximum accuracy. You are trying for getting to the maximum accuracy with a good one. Okay, that is called as optimization. So in the job description, they clearly write you have to optimize the model. Optimize the model means as per the requirements, you have to modify the models. As per the requirements, you have to modify the models. For example, one requirement will be accuracy. One requirement will be based on the precision. One requirement will be based on the F1 score, something. So you have to identify the better model which gives the as per the business problem, which satisfies the business problem. You have to try with the different models. Within that different models, you are going to do the optimization. So here pruning is also considered as an optimization. Hyperparameter tuning is considered as an optimization. Regularization is considered as an optimization. All these techniques, everything is called as optimization. Everything is called as optimization. Every technique which leads to increase in the accuracy, which we are trying to increase to the betterization of the accuracy, every technique is called as optimization technique only. Every technique, whatever the technique you are applying in order to get the better model is called as optimization technique. Now, here within the decision tree, we are going to do the optimization. So if you observe here, I'm having total 20 records are there. The X-Days example, I'm having total 20 records, out of which 20 records, 10 of them are positive and 10 of them are negative, right? Means 10 of them positive means 10 of them will play the cricket and 10 of them are doesn't play the cricket. They don't play the cricket. So yesterday's example, whatever we have done, and we are going to divide the data like this, and finally we are going to get the leaf node. Leaf node means in this every one person is going to play. In this every person is not going to play. In this play, not play. Now if any future data, if you want to predict whether the person will play or not play, means first you have to send that details into this one. Here one condition will be there, and based on the condition, either that belongs to this one or this one. Again, you are going to write check here the condition, and based on the condition, either it belongs to either of these two. Again, you are going to check one more condition, and from that you are going to identify to which leaf node it belongs to, and whatever the final answer is there, that one is the final one, right? Yesterday we have seen this one. Now here I'm having like this. Now in this, if you want to do some kind of optimization, how we can do the optimization means the optimization is nothing but pruning. Now how we are going to do the pruning means there are multiple options are there. Option number one is called as minimum samples required for the node split. By default, the minimum samples is going to be 2. By default, it is going to be 2. So for example, a node is having of 1 plus and 1 minus. Still, it will be splitted. One as 1 plus and as 1 minus. Okay, till you get the pure class as the output, it will be splitted. All the records will be splitted. So the minimum samples required for this node split, right? So here by default, it is having the 2. Now what I'm going to do is I'm going to increase. Okay, I'm trying to increase that one. So I'm keeping the minimum sample is 10, assume. Now here 20 are there. Since the original data consists of 20 records, I'm splitting the data. Now after splitting the data, now I have got this side 10 records, this side 10 records. Since in this node 10 records are there, so it is getting furtherly splitted. In this also 10 are there, it is getting furtherly splitted. But here it is not getting furtherly splitted. Though it is having the 2 categories, 1 plus and minus also is there. Still it is not getting splitted. Why it is not splitting means because in this the minimum sample of 10 is not there. It is not satisfying that one. So it is not going to split that one. So it is not splitting means I'm going to stop the decision tree here only. Instead of continuing like this one and this one to furtherly extended, I have stopped the decision tree by writing the word called as minimum sample is equal to 10. Now, sir, how you decided this minimum sample is equal to 10? I don't know that value. So here we are going to do the hyperparameter tuning. Okay, we don't know that number. 10 is not a fixed value. 10, we are going to do the hyperparameter tuning. So higher values controls the overfitting. Too much of higher values can lead to the underfitting. For example, if you have given 20 or 24 minimum samples for the node split is equal to 24 you have given. First only as a decision tree only will not start. Even the decision tree will not start because here only total records only 20. If you write here 24, what happens? Decision tree will not start. For example, you have written some kind of 12. Now what happens? It is going to split these two. It will not even split this one also. It will not even split it here. It will stop here only, because here 12, it is not meeting the 12 requirement. It is also not meeting the 12 requirement. None of the node is satisfying that minimum requirement. So they are not getting splitted, right? So here high values, if you increase to some extent, it will control the overfitting. Too much of high values leads to the underfitting problem. So we have to do the proper hyperparameter tuning. Next, minimum samples required for the terminal node. So in the terminal node, for example, I'm writing of 5. For example, if it is getting splitted, if this data is getting splitted, I'm going to get in one of the node as 4, 7, and in one node 3 I'm getting. So first initially 20 are there. First I have splitted 10, 10. If I split this one, I'm getting 7, 3. If I split this one, 5 and 5. Here the minimum sample required for the terminal node. In the terminal node, 5 and 5 satisfying. So this can be splitted, no problem, because you are getting 5 and 5. Minimum 5 values you are getting in one node. Here, if 10 are there, one node is satisfying the condition, but another node is not satisfying the condition. So this split should not be there. So it is going to remove this one, and we are going to get only with respect to this. Why it is not getting splitted? The reason behind that, why it is not getting splitted, means one side you are getting 7 and one side you are getting 3. But what is the minimum sample required for the terminal node? Means 5 is the minimum sample. It is satisfying that 5. This is satisfying, but this is not satisfying. Since it is not satisfying, so we are not going to split this one. Sir, if it is not satisfying, you can split up to this one, 7. This is not satisfying. It will not split like that. Splitted means 2 parts. If it is any node is getting splitted, means it has to split into 2 parts. It can't be splitted into 1 part. Split happens means 2 parts it has to split. Otherwise, it will not split. Simple. Right? So here again, once again the same. Higher values controls the overfitting. Too much of higher values leads to the underfitting. Similarly, maximum depth of the tree. So you are going to give the maximum depth. For example, you have written the maximum depth is equal to 1. Maximum depth is equal to 2. So here you are going to get a maximum depth of 2. So next it is not going to split furtherly. So by using the maximum depth, these are the different hyperparameters. Either you can use with respect to minimum number of samples for the split. Either you can use with respect to number of samples in the terminal node, or you can use the maximum depth. And the last option we are having is called as maximum number of terminal nodes. If you write that maximum number of terminal nodes of this one all I want. For example, I'm writing the maximum number of terminal nodes is equal to 2. What is meant by terminal nodes? Terminal nodes is also called as leaf nodes. So here I'm having only 2 leaf nodes. I'm writing only number 2 means 2 only I will get. For example, if I'm writing 3, if I'm writing the maximum number of terminal nodes should be equal to 3. This is the maximum. If you split also, maximum should be 3 only. So it is going to be splitted like this, 1 and 2. Now, so here I'm going to get 1 terminal node, 2nd terminal node, and 3rd terminal node. 3 terminal nodes overall. In this decision tree, overall 3 terminal nodes. Now your question would be, sir, why you have splitted this one only? Why you can't split this one? Yes, either this one or this one will be splitted, which is having the Gini impurity high, which is having the lowest Gini impurity, or with respect to information gain high, that will be selected and that will be splitted accordingly. For example, if I have given the maximum number of terminal nodes is equal to 3 means, I'm going to get like this. If I have written the maximum number of terminal nodes is equal to 4 means, I'm going to get like this. If I write with respect to maximum number of terminal nodes is equal to 5 means, now tell me in this case, what is the maximum number of terminal nodes? 1, 2, 3, 4, and 5. Is that clear? Like this, I'm going to get with respect to maximum number of terminal nodes. So now again, so total 4 options we are having. One is minimum samples for the node split, means that is node split means decision node. Minimum samples in the decision node. Minimum samples required in the decision node. Minimum samples for a terminal node. Maximum depth of 3. Maximum number of terminal nodes. These are the 4 different options are there. You can do the 4 different options hyperparameter tuning. That I'm going to apply the param grid. I'm going to take the param grid. Within the param grid, I'm going to take the dictionary. Within the dictionary, I'm going to write maximum depth. Maximum depth. I'm going to give 1, 2, 3, 4, 5, 6 like this. So first it will try with a maximum depth of 1. Later it will try maximum depth of 2, followed by 3, followed by 4, followed by 5, followed by 6 like this. And which is having the maximum accuracy, it is going to identify. Hyperparameter tuning is there. You don't need to do anything manually. So just you have to substitute the values. Now, how much of the values you have to substitute? In the minimum samples or maximum depth of the tree or maximum number of terminal nodes, how many number of values I have to substitute? Sir, maximum depth 1, 2, 3, 4, 5, 6, 7, 8. Up to what is the maximum number I have to write, miss? That you have to decide based on the first you have to create a default model. First you have to create a default model. In the default model, you have to grow the entire tree till the end. Till the end, you have to grow. Without doing any kind of pruning, you have to go. Miss, which leads to the overfitting. First, you have to see the overfitting problem. From that overfitting problem, after observing the tree, then you can decide what we have to do. Without seeing that one, we can't decide what is the maximum number we have to provide. Right? Is that clear, guys? Yes. Terminal nodes means nothing but number of leaf nodes. Exactly. Is that clear, guys? So this is one way of reducing the overfitting problem in the decision tree. There is one more way of reducing the overfitting problem. That overfitting problem reduction is called as assemble technique. One more way in order to reduce the overfitting problem in the decision tree is called as assemble technique. Now, assemble technique, what is meant by this assemble technique means here, instead of considering one decision tree, I'm going to consider the multiple decision trees. Okay, multiple decision trees. Since I'm considering a multiple decision trees, so more number of trees are there. So it is called as forest. So I'm going to select a forest. Assemble technique name is called as forest. Now, forest means nothing but having the multiple trees. Now you will get a question, sir, for a given data, one decision tree only is possible. How you can create the multiple decision trees? One more decision tree you have to create also. Again, you have to calculate same decision, same gene impurity, same information gain. Everything is same only. Now calculations will be the same. Then how you can create multiple decision trees? Multiple different decision trees you have to create, not the same one. Multiple different decision trees. What is meant by forest means? Meaning of forest. Forest meaning is multiple different trees. Multiple different trees combination is called as forest. Multiple trees. Okay, multiple trees. You have to take the forest means nothing but multiple trees, not the same one, different one. Multiple trees which are different to each other. Now, sir, okay, you are saying that to create the multiple trees. Let us understand this one. Let me show you the PPT. So here I'm having a forest. A forest. Forest means multiple trees. Tree 1, tree 2, tree 3, 3, 4, 5, 6. Like this, I'm having 40 to 50 trees or 60, 70, 80, 90, 100. Whatever the number of trees I want to create, I will create. Now, so here you are going to create the multiple. It is going to create the set of decision trees. And from that set of decision trees, it is going to combine the words. So, for example, a new data is there. Completely a new data is there. A new data you are going to send into the tree 1 and you will predict the output as either class 0 or class 1. And you, for example, you have got in this tree the answer as class 1, assume. The same new data will be transferred into the second decision tree and you have got the answer as class 1. You have sent into the third one, you have got the class 1. Fourth one, you have got answer 0. Fifth one, you have got the answer as 0. Sixth decision tree, 0. Seventh decision tree, 1. Now let us assume total 7 decision trees I have created. And this data was transferred into the all the decision trees one by one. And after that, whatever the answer I have got, from that I'm going to take the majority vote. Since my majority vote, I'm having the majority vote. First decision tree has given 1, second decision tree 1, third decision tree 1, fourth decision tree 0, fifth one 0, sixth one 0, seventh one 1. Now out of 7, which is having more number of ones and how many of them are more number of zeros? Which is having with respect to, which is classifying. So 1 is getting classified by more number of decision trees. So I'm going to, for this new data, I'm going to predict the answer. Yeah. Online students is clear. Done. Topic is clear or voice is clear. So here we are having in terms of done. So we are having in terms of a multiple decision trees we are going to formulate. And from this multiple decision trees, each decision tree, whatever the multiple decision trees we have created, from each decision tree, we are going to send the new data into each decision tree. And from each decision tree, we are going to identify the answer. And after that, we are going to apply the majority vote on that, on the test data. So here it is going to combine the votes for the decision trees to decide the final class of the test object. On the unknown data, if you want to calculate anything, it is going to pass into the multiple decision trees. Now the question is first how these multiple decision trees are created. For a fixed data set, how multiple decision trees will be created? One decision tree, it will be created. How multiple decision trees will be created? For example, I'm having a data set something like this. X1, X2, X3, X4, X5, and Y output variable, where I'm having the class Yes or no, either class 1 or class 0. Something I'm having like this. Assume I'm having the records. Total 10,000 records are there. 10,000 records are there. And I'm having the data like this. 10,000 records. Now for these 10,000 records, first for each column, I'm going to calculate the Gini impurity. And which is having the lowest Gini impurity, that particular column I'm going to select. For example, X3. Using the X3 column, I'm going to divide the data into 2 parts. And from that, I'm going to again recalculate the Gini impurity. Again, I'm going to recalculate again. The same process will be continued. Now, second decision tree, forget about the first one, second one. Now, second decision tree I want to create means again the same calculation only, na? Again, same calculation, again, same Gini impurity. How I can create then multiple decision trees here? So here, the multiple decision trees are created completely based on the random subset of the data. Means you are going to create the first decision tree, not on the complete data. Earlier, whatever the decision tree algorithm, you are having the decision tree algorithm, na? Decision tree algorithm use entire data. It is going to select the entire data. But in the random forest, the first decision tree is not going to take the entire data. It is going to take the subset of the data. Some part of the data. So it is going to take the part of the data from part of the given data. Means part of the entire data. Whatever the entire data is there, within the entire data, it is going to take part of the entire data. Sir, how it is going to select that part? On what criteria it is going to select the part? Randomly. Randomly, it is going to choose that one. Randomly, it is going to choose the subset. That is the reason it is called as random forest. The subset of the data is chosen randomly. Now, is there any criteria for choosing that one? Nothing. It may choose only 2 columns. It may choose 3 columns. It may choose some part of the, okay, for example, I want to choose 3, 4, 5, 9, 10, 11th record of X1, X2, X3 variable. Only these 3 variables, only these 3 rows. It may choose anything. There is no restriction. Okay, these many number of columns should be there. These many number of rows should be there. There is no restriction. For example, sir, here you are having the 10,000 records now. Decision tree number 1 is using 2,000 records. Decision tree number 2, 2,000 records. Decision tree number 3, 2,000 records. Decision tree number 4, 2,000 records. Decision tree number 5, 2,000 records. Everything are using 2,000, 2,000, 2,000, 2,000. Total 10,000. Now, only 5 only I can create, right? Here, it is not with respect to 5. I can create even 100 also. 100 decision trees also I can create. 200 decision trees also I can create. 500 decision trees also I can create. So there is no restriction. Whatever the maximum number of permutations and combinations are available, everything I'm going to take. So it is going to choose the randomly the subset of the data without any restriction. Now, sir, for example, decision tree 1 has chosen some records. It has chosen some records. Some records are chosen. Now, decision tree 2 will choose the within that same records or different records, means it can choose the same records once again. There is no restriction. Means here the first decision tree and the second decision tree are independent to each other. The second decision tree, third decision tree, whatever the decision trees are there, all the decision trees in random forest, all the decision trees in the random forest are independent to each other. They are independent. Sir, what is the meaning of independent? Whatever you have chosen in the decision tree number 1, it will not even consider. It will, for example, you are creating the decision tree number 2. According to your perspective, it is 2. But from random forest, it is the 1 only. It will not think that, oh, already one decision tree was created, I am the second one. It will not think in that way. Irrespective. There is no connection. There is no connection. Okay, already decision tree number 1 has chosen these records, so I should not use those records. It will not have any connection. Everything are independent to each other. There is no connection between them. So in the all the decision trees in the random forest are independent to each other without no connection. So you can choose any records of your choice in the decision tree 1, in the decision tree 2, irrespective of 1, you can choose again, once again. Means every time it is completely new data set for you. Every time for each decision tree, every time it is a new data set. For example, first decision tree, how many options it is having to choose means total 10,000 records are there into 5 columns are there. It can choose the data between 10,000 records with the 5 input columns, anything it can choose. Now the same probability is there for decision tree 2. Same probability is there for decision tree 3. Same probability is there for decision tree number 4. What are the probabilities associated for decision tree 1 to choose the data? The same thing is there. So it is called as bootstrap. This is called as bootstrap. Bootstrap means in terms of a repetition of the data is allowed. A repetition of data is allowed. Is called as bootstrap. Okay. Bootstrap. It means a repetition of the data is allowed. The technical word. General word is repetition of the data. These are in the random forest, the data will be repeated. So the data will be repeated means you have to say, so random forest is a bootstrap technique. Bootstrap technique means automatically it is accepting the repetition. Some other algorithms will be there. They will not accept the repetition. For example, let us take like this. In a university, we are having a university. In the university, there are final year students. Final year students of approximately 3,000 students are there in the university. Final year students. And companies has to come for the campus placements. Companies are coming for the campus placement. Companies for campus placement. Now, first company has came. And it is choosing the around 80 students. 80 students it is going to select. 80 out of 3,000 students it has selected. Completed. The first company completed. What are the company? Forget. Company name. Assume it is TCS and it has selected 80 students from the 3,000 and it has went away. Now second company. Second company came for the campus placement. Now this time the company wants to select 50 students. That is the company requirement. They want to select the 50 students. Now 50 students out of what? Out of 3,000 or already 80 students are completed now. So 50 students out of 2,920 now. 2 options are there. 2 options are there. Already the students who has got the company offer 1, they are not eligible to sit in the company of for the next company. This is option number 1. Now, if it is not, the university has made a rule like this, means automatically the second company is having the probability of 50 divided by 2,920. If that is the rule. If that rule is not there, then automatically again the same 3,000 students can sit in once again. And now the company is having the same probability to select out of the 3,000 students. This will be done by normal colleges. Generally for normal colleges, this rule will be there. Because they want with respect to maximum number of students for the placement. They want with respect to the students, more number of students has to be placed. For that, if one student is getting 1 offer also, they will satisfy. Okay, in a normal colleges. But in IIT or IIM, what happens means you are having the free to sit with respect to multiple companies. One student can have even 10 job offers also. When I'm in the BITS plan, I used to have 4 job offers with my hand. Okay, there is no restriction. We are not having any restriction. So that is the reason why the companies also will be interested to come to the universities. For example, for TCS, you are giving the 3,000 students and you are asking to select out of 3 students, which is the top students, you are giving a chance for TCS. Assume the second company is Infosys. Now for Infosys, if you are giving only 2,920 means, why you are not giving that remaining 80 students, bright students for Infosys? Already TCS has selected them means they're bright students only, right? They're having good subject knowledge. 80 students are already bright students. Now why you are not providing that 80 students for the Infosys? Means You don't want to share us the bright students. You want to give us the waste students. And in the waste students, we want to select the remaining batch. The Infosys team will feel in that way. They will feel. So they'll feel that why you are not providing the remaining 80 students. Maybe in that 80 students, very extraordinary talented person is there. We may hire na. Why you are not providing for us that extraordinary student? In any university, one university topper will be there. For any university, one topper will be there. Common, that is. Whoever is in the first position, they are called as university first ranker. You are providing already the university first ranker was selected by the TCS company. Now that university first ranker, you are saying that you are not eligible to sit in the Infosys, miss. You are not eligible to sit in the another company, miss. What is a mistake done by the Infosys is to come in the second line, second position for the campus. So now Infosys people will ask that we will only come for the first and next time we will take the initially out of 3,000 students in the first initially. They will say that we will come. Now this time TCS will feel. So the same thing happens in the normal colleges. But in IITs, every company is equal for them. Irrespective. Whatever the process by TCS you want to conduct, you conduct. Whatever the process you want to conduct, you conduct. Separate. They are independent to each other. There is no restriction. Okay, you are already has got the job in TCS, means you are not eligible to sit in this one. We are not going to say that to the students. And we are not going to give the instructions for the companies also that, sir, already who are having the job offers, please don't select them. We are not going to give any restrictions for the companies also. Simply we are saying that, sir, we are having total 3,000 students. Whatever the number of students you want, try to hire the maximum number of students if you feel them they are having a good subject. Only one thing we are going to say for them. Right? In this, now the random forest works in the same concept, where with respect to repetition also allowed. The data can be repeated. So the random forest, it is going to overcome the problem with the single decision tree. Whatever the single decision tree is having the problem called as noise or overfitting problem. Now it is going to overcome that one by taking the complete data. What are the complete data? Whatever you are providing for the training set, that is X train, Y train. Within that only, it is going to divide into the multiple parts. And after dividing into the multiple parts, now how many parts it is going to divide? How many decision trees it is going to create, miss? That is the hyperparameter tuning. So by default, the number of decision trees are by default is equal to 50. So it is going to create the 50 decision trees by default. If you want to increase or if you want to decrease also, you can do. That is hyperparameter tuning. Try with the number of decision trees is equal to list of range of 1 to 100. So decision tree will be one. After that decision tree, 2 decision trees, 3 decision trees, 4 decision trees, like this. 1.2 decision tree is possible. Can you give 1.2 in this? No, that we have to write. So here what I'm going to give is list of range of 1 to 100. First it will try with 1 decision tree, a single decision tree. Now it will try with the 2 decision trees, 3 decision trees, 4 decision trees, 5 decision trees, 6 decision trees. And after that, it will only identify which number of decision trees is very good for the given data. Sir, to be more simplified, our entire machine learning is a trial and error only, right? That is the actual. Our entire machine learning is trial and error. From starting to ending, everything is trial and error only. There is no fixed answer in the machine learning. That is the reason everyone will feel the machine learning is a difficult subject. When we'll do generally the trial and error, when the questions are difficult, instead of doing the manual calculation step by step, we'll make a trial and error. And if, for example, in the aptitude question, if something was given for us, instead of doing the calculation, we'll try to substitute option A first, followed by option B, option C. Like this, we'll substitute the given options. When you will do that one, when you'll try to substitute option A first, option B, option C, option D, when you will do like that, when you will do the normal calculation and you'll select the answer, in 2 options are there, right? For example, there is one MCQ question. Let us take an example like this. There is one MCQ question. And for this MCQ question, there are 4 options are there. 4 options are there, A, B, C, D. One way of solving the problem is directly you are going to complete the question. Directly you'll solve the question. And from the question after solving, whatever the answer you have got, you are going to check this answer is either in the A or B or in the C or D, and you are going to make a tick mark on that. This is option number 1 of solving. Second option of solving is we'll try with A, we'll try with B, we'll try with the C, we'll try with D, and which gives the given equation which satisfies, that one we are going to select. When you are trying like this, when you are trying like this, when you'll do that one, when you'll do this one. If this is a complex example, if it is a complex problem, then in that case, we can't able to solve manually. In that case, we'll try with the 4 options. If the question is very simple question, we'll not even see the options also. Directly we'll do the first mathematicals, and after that, whatever the answer we have got, that we'll see in the this one. Right? For example, 2 plus 2, A 4, B 6, C 8, D 10. If I give like this, are you going to see the options, or first you solve the max? The same question, 2 to the power of x plus 3 to the power of minus x is equal to 9. Option A, x is equal to, what is x value? X is equal to, if I give 4 options, are you going to do the mathematics, or you are going to substitute the options? So in some examples, we'll do like this. In some examples, we'll do like this. This is a common, everyone knows. And in the other subjects, other than data science, machine learning, we are having a systematic pattern. Okay, first we have to do this one, followed by 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 this one. Everything is systematic, and this one. Okay, this is the case means you have to do like this. If this is the case means you have to do like this. If this is the case means you have to do like this. Means simply to say a mini size robo, our work is. But in data science or in machine learning, there is no fixed rule. No fixed rule. For the entire data, anything can be there. What is going to happen, we only don't know. So we have to make the different trial and errors. That is the reason why machine learning and data science, many of the students will say outside in the market, it is a difficult subject. Basically, it is not a difficult subject. Basically, it is a more time consuming with respect to trial and errors. We have to make the multiple trial and errors. Means first we have to think of the options. What are the multiple options are available for this? And from that, we can make the trial and error. Right? So here we are going to take the random subset of the data. You are going to divide into the random subset. And for each subset, you are going to create the decision tree. And from the each decision tree, finally, you are going to take the voting. So in this way, what happens means you are trying to reduce the overfitting problem. So first you are going to divide the data. Dividing the data with repetition is called as bootstrap, where the repetition also allowed. And finally, from each decision tree, you are going to make the voting, which is called as aggregation. So this random forest, whatever the random forest is there, random forest is also called as bootstrap aggregation. This is also called as bootstrap aggregation. Okay, bootstrap aggregation. Now, bootstrap aggregation shortcut is called as here B, here AGG, bagging. Okay, bootstrap is also called as bagging technique. Okay, bagging, meaning of bagging means B stands for bootstrap, AGG stands for aggregation, because you are aggregating finally with the voting. ING, if you are saying without using ING, if you are using that technique is called as bag technique. Bag technique means everyone are saying that as a bad technique. If you say this one as a bag technique, bag, instead of using the word of bag, if you are saying as a bad, it is converting as a bad technique. So that is the reason they have added the word called as ING. Nothing special in the ING. Bagging. Okay. So now bagging technique. Random forest means bagging. What is the meaning of bagging? Means bootstrap aggregation. You are bootstrapping means repeating the data and creating the multiple decision trees. And finally, you are going to aggregate that one. Is called as bootstrap aggregation. Is that clear, guys? And advantages is it is going to reduce the overfitting problem. That is the advantage. It is going to reduce the overfitting problem. And these decision trees and random forest are used for the both regression and classification purpose. Decision tree having with respect to decision tree classifier and decision tree regressor we are having. Similarly, random forest also classifier, random forest classifier, and random forest regressor. Okay, regressor. So now it is going to both random forest and decision trees are applied for the classifier and regression purpose. Now, how the decision trees works for the regression data? Earlier, we have worked on the mode or voting, where we have taken the mode or with respect to voting, where we are having this one is with respect to by applying the voting. Voting means nothing but mode, which is most repeated. Voting means nothing but mode. Now, regression means we are going to take the average from each decision tree, whatever the value we have got, we are going to take from the multiple decision trees, multiple values you are going to get this time, because the output is a continuous variable. Continuous variable means you are going to get a with respect to the values. So that values you are going to take the average. So that is called as random forest regressor. Now, how the decision tree regressor is created? Already we know decision tree classifier. How regressor is created? Regressor also is created in the same way how the classifier is created. Same Gini index, same everything. Now, instead of considering with respect to the Gini or information gain, we are going to take the variance. By using the variance, we are going to divide the data. Okay. Is that clear, guys? So same in terms of how we have worked for the decision tree classifier, same way for regressor, but this time variance. For coming to the random forest regressor is going to work on the average concept. Multiple decision trees, from each decision tree, it is identifying the what is the average value. Right? Is that clear? So that is with respect to the decision trees and random forest. Any questions with the decision tree and random forest theoretical part? If you have any questions, you can ask. You can ask. What are the questions you are having? Yes, that is classifier only now. Output variable is continuous means regressor. Output variable is discrete. Yeah, guys. Online students. So it is clear the theoretical part of decision trees and random forest. So today there is a slightly network issue. At the same time, power cut issues also there. So multiple times we are having the power cuts. Okay. So let us continue the class in the tomorrow's session. And that is the coding part of decision tree and the coding part of random forest. We are going to work on the tomorrow's class. Done. So theoretical part was completed and coding part we'll see in the tomorrow's class. Okay. Tomorrow, Saturday. If possible, I'm going to take the class tomorrow also. Online students, if possible. Okay. Just I want to confirm with the Naresh IT team whether there is whether it is getting opened or not. So I can't confirm right away. If it is possible, I will conduct class tomorrow. If possible, I will conduct the class tomorrow. Okay. Same thing I'm going to intimate in the Google Classroom. I will intimate in the Google Classroom by maximum 1 p.m. itself. Not even 3. By 1 p.m. itself, I will conclude. Okay. If in the Google Classroom, if I write that there is a class miss, please try to attend tomorrow's class. Yeah, tomorrow if I complete this, because theoretical part you have completed, right? Now immediately if you learn the practical part, then the subject you'll understand clearly. Otherwise, what happens means if I extend to Monday, there is a high problem. So that is the reason I want to do that in the tomorrow's class itself. Okay. I want to conduct in the tomorrow's class, if possible. Done. So that is the end of the session, guys, and we'll continue in the tomorrow. Yes, same time. Same time. There will be no difference.